Okay, welcome to the November 23rd OMR Architecture Meeting. We have a fairly full agenda today. We have a number of compiler topics to get through. The first topic is a new opcode, IL opcode proposal from Spencer. So I'll turn it over to you.
All right.
To take us through that.
Am I close enough to the mic here? Can I be heard?
Probably. I think so.
Okay, perfect. Let me share my screen here. All right, if I go to presentation mode, that doesn't break anything, right?
Not for us.
All right, I'll just not go in presentation mode. I'll not take that risk. All right, yeah. So proposing some bit compress and expand opcodes. So just a bit of I guess review, technical overview for anyone who's not familiar with the bit compress and bit expand operations. Also known as bit extract and bit deposit, or bit gather, bit scatter, lots of names. So just here's that 8-bit example. So bit compress, you have your source, you have a mask, and then your mask tells you which bits to pick from your source and shifts them all to the lower bits of your destination. Bit expand, it's kind of the opposite. You use the mask to tell you where to put your bits in the destination, and you just start from your lowest bits in your source. So like you can see here, the mask tells me where I put the bits and how many. So in Java, there's 4 intrinsic methods: integer compress, long compress, integer expand, and long expand, that directly map to these operations. There's also 2 vector operations that do the compress bits and expand bits. And those opcodes, the vcompress bits and vexpand bits, those are already existing in OMR. And then what I'm proposing here is adding integer and long compress bits and expand bits. Any questions on this slide before I move on? So you can see on x86 and power, there's instructions that directly map to these operations. So be a pretty, assuming the instruction is efficient, then be pretty efficient, just one instruction implementation, maybe 2 if you need to do some extension or something. So for the example of integer.compress, we could map that directly to the iCompress bit opcode. And then, like I said, there's just one instruction generated for that. And I did implement this and test it out. It works just fine on x86. One other place where we could use the compress bits, bit compress bits. So for profiling, when we do a profiling compile, we do use a bit index hash. So we implement that with a bit from use node. There is a bit math cache that directly maps to compress bits operation. I think currently it's unused, but all the infrastructure is already there. If you have any questions on this, I'd direct them to Rahil and Drew. They know more about the profiling than I do. And yeah, that's it. Any questions, comments? What do you all think about adding these operations?
I guess there's a certain symmetry already. The example you gave was an 8-bit example. Are there 8-bit variants of this opcode that you or 8 or 16-bit variants of this opcode that you think should be added as well? Like a B compressed bits?
They could be added. I don't see why not. I just have the 2 because I was looking at the x86 instructions and it directly maps to 32 and 64. But
okay, I mean, if there is, and I'm not sure off the top of my head, if there is hardware implementation for those, I would think we may as well add those opcodes rather than an incomplete set.
yeah, that makes sense. Yeah, I don't know of any hardware implementation that does the 8 and 16-bit version of this, but
I guess the one place where we have the extract and expand instruction is the x86. Does it have a 8-bit and 16-bit version?
I don't know. I have to check. I don't know off the top of my head.
yeah, I've only seen 32 and 64 on x86. I was looking into this.
So does he have equivalent set of instructions? Or?
No.
Are we actually, I don't know if any Gita's here or not. No. Do we actually do anything with on the vector side with these, or is this? So we had a like sort of a legacy set of vector opcodes that we had accumulated over the last 20 years. Is this, are the V versions of this? Are they? Do you know if they are? Is that part of the vector API work?
Yeah,
So you would know that.
that was proposed by Gita as part of a vector API
Okay.
work.
Okay, so I guess x86 just isn't done yet then?
I believe so.
Mm-hmm.
But those are still not implemented, right? The vector, that means the infrastructure is there, but I don't think there is any code that is being generated for that.
No, I think it's ongoing work, especially this V compression, V expand is around probably x86 and Brad would be doing the work. But I guess work in progress.
Yeah, there might be instructions that those directly map to. I just didn't see them in time to put them in the slide here.
Okay. So presumably, or I shouldn't presume, but what are the types of the, so let's say L compressed bits, it's going to be I, in this case, I is going to be a long and mask is going to be a long as well?
Yeah. Yeah, so the integer would be 32-bit output and 2 32-bit children.
Are there simplification opportunities here? So for example, if you do an L compressed bits of a long with all ones, for example, your mask is all ones. Is that like an identity operation?
Yeah, if your mask is all one identity operation, in both cases, for compress and expand. And if your mask is all zeros, then it's a 0.
Okay. Are you going to teach the simplifier that? I don't, because otherwise I think we just do a very, whatever the default simplifier that we run on these things, which won't really do anything.
Yeah, I could figure out how that works.
That requires us to know what, like a value propagation or something, to know that what the mask value is, right, at compile time.
Yeah, or it could be a constant, I guess.
If it is a constant, then even the code gen can directly bypass things, right, if it is a constant.
It could.
Yeah, if
we can
do that.
I mean, I guess if we could do it in IL, why, or we could eliminate it in IL, why
Yeah.
wouldn't we?
Yeah, Comin and did it earlier.
And I guess the other thing would be, are these going to come with trill tests as well?
Yeah.
Right. Any objections to from anyone on introducing?
I think you're probably going to do this anyway, but you should check some of the other arithmetic operations to see what the flags are so that they're optimized to the degree that they should be by processes like PRE and other processes. So just mimic one of the other arithmetic operations, I guess, IAD or something like that.
Okay, yeah.
So these are basically same instructions that handle different lengths, like I and L.
Mm-hmm.
So presumably it can handle any arbitrary length.
The instructions or the
instructions.
opcode or if you do the correct 0 extension, you could do the 8 and 16 bits with the same instructions.
Okay, any other discussion people want to have on this? I think there's, in the absence of any objections, I think there's agreement that we can let this go ahead. All right, I need a gavel. Okay, all right, thanks, Spencer. Okay, so our next topic is Const correctness in the OMR compiler APIs. So this is some work that Dylan has been doing to eliminate the large number of compiler warnings that are coming out of the compiler code as you're building it. So he's been doing some work to eliminate Const correctness. So he's just going to lay out the what he's done and what he plans to do. So I'm going to turn this over to Dylan to take us through it.
Yeah, I don't have any slides. I just have a diagram in a couple of minutes here, so I'll just hold off for now. But yeah, if you haven't had a chance to meet me yet, I'm Dylan. I'm a student on the Optimizer team. I'm just wrapping up my 8-month internship here. For the last few months, my main task has been to fix a whole bunch of warnings in the JIT to turn on warnings as errors. A little bit of background, a few years ago, we already eliminated warnings on X and Z, and we turned on warnings as errors there. Last year, it seems we got most of them out of the way, but we weren't able to flip the switch. So when I took over, there was only one warning left on ARC64. And so that was really easy. Fix that up, turn that on. And so that just leaves power. Between P-Linux and AIX, we have 12 unique warnings. Some of them were super easy to fix. Some of them were a little bit harder to fix. The one that took the most work was this warning concerning string literals, which have type const char star, being implicitly converted to type char star. There were nearly 6,000 instances of this warning throughout the code. And so I had a lot of work to do there. There are two ways that you can fix this warning. You can either cast the string literal to a char star, or you can change the type of the variable or function parameter that it's being passed into to a const char star. The first way would be a lot easier. It would have been a lot faster if I had done it that way the whole way through. But it's kind of ugly. It clutters up the code a little bit, and I feel like it's kind of a hacky solution. And so the proper way is to try your best to make the variables and function parameters const if possible, and then only do the casting if it's absolutely necessary. We're pretty lucky because there aren't very many situations where you have to resort to casting. when you have a const char pointer, you can reassign it as many times as you want freely, but you are not allowed to mutate the characters that the pointer points to. So that takes up a small minority of cases. So we don't have to put that many casts in the code, which is nice. The real work that was involved in this process was the propagation of constness throughout the code. If you change one variable to be const, all of a sudden there are all these functions that it's getting passed into, and you need to change the function parameters to be const. And then those parameters get passed into further functions, and you get the idea. The ripples can spread quite far in certain places. So as I was going through fixing all of these warnings, I made the arguably dumb decision to do it all in one giant commit on one giant branch. And if you had, when I had finished, if you had put it all into one commit between OpenJ9 and OMR, it would have been about plus 1200 minus 800 kind of levels of changes. And so I obviously had to split up the giant monstrous commit into chunks of easily reviewable components that you can merge one at a time without breaking the build. I decided to split the commit up into one commit per component. So one for control, one for optimizer, one for runtime, and so on. And then I ran a whole bunch of builds to determine what the cross-component dependencies were. And I ended up with this dependency graph. So I should have added a legend that would have been helpful. The red nodes are J9 components, and the blue nodes are OMR components. The nodes that are circled in black have two-way dependencies. So if you merge only one, then the build fails. If you merge only the other, the build fails. So these components, particularly across OpenJ9 and OMR, have to be merged in coordination with each other. And I used this graph to determine the order in which we have to merge everything in. So I split up here into 4 steps with a few nodes that can be merged at any time you like. As of today, step 1 is merged, so that's great progress. And we'll be continuing to move through those steps until they've all been merged, at which point we can enable warnings as errors on power and enjoy the added safety on all 4 of our platforms. So there are some important things to take away from this, which is it introduces some minor inconsistencies to some of the OMR APIs. You'll have some situations where some methods might have const parameters and some similar methods don't, just because the way I've been working on this is to go through cases where warnings are thrown because you're passing string literals into these parameters, for example. We determined that, this isn't ideal, but trying to perform some kind of comprehensive sweep of every variable, function parameter, method parameter in the whole code that takes a string and doesn't mutate it would be a bit beyond the scope of what's possible for an intern in a few months. And so we're, and we think that these incremental changes, although they're incomplete, have value not only for enabling us to turn on warnings as errors, but also to bring some amount of const correctness into the affected APIs, which is sort of the discussion that, why I'm talking here today. Partly because, this is a rather broad change that affects many parts of the code, and it's probably a good idea to let the community know that this is happening, but also because there are some interesting philosophical implications involved. I don't think anyone here needs to hear from me what const correctness is or why it's valuable in general. I think this is just a convenient opportunity to maybe discuss the merits and drawbacks that could be involved in adding const correctness to some OMR and OpenJ9 APIs. But yeah, that's what I've been working on for the last few months, and thanks for listening.
When you are doing these changes to fix power, is there a possibility of breaking on other platforms or no?
I've been, whenever I have been getting my fixes on power ready, we've been testing on other platforms. So I suppose there's the chance that if someone made a change in another part, in say a common part of the code, that could potentially make the AIX compiler angry if you don't test on AIX, but I think that's probably generally a bad idea to not test on all the platforms anyway if you're working on common code. So I don't think that should be a huge issue.
No, I was just trying to see if there was any conflict,
right,
where one compiler thinks something is right versus other things.
Right. We haven't run into any situations like that. It's just some seem to care about it as a warning more than others.
Okay.
Can you bring up that diagram that you had again?
Sure.
So the black circles, they represent changes that have to go, coordinated changes that are required in OMR and OpenJ9. So does each colored oval there, is that a separate pull request or is that just a commit?
Each of those is a commit.
Okay, and, so let's say the thing on the left, you've got one OMR PR and one OpenJ9 PR that have to be merged together. It's not. Okay.
What I've done here is each of these steps is a pull request. I could split them up if that would make it a little bit easier. For example.
No, I think if you have things that need to be coordinated, fewer things to merge, push the button on, the better. So
yeah, that makes sense.
One OMR, one OpenJ. Okay.
Sure.
I mean, I think.
Are the volume of changes across those steps kind of similar, or most of them are in one bucket?
It's, I think the largest number of changes in terms of like lines is in env and control. And so steps 2 and 3 are going to be a little bit bigger than the rest. But I mean, it's not like it's extremely different or anything. They're all relatively in the same ballpark.
I think in general, the const correctness is a good thing going forward. I mean, certainly when a lot of these APIs were originally developed, that wasn't really a consideration at that time. I mean, some of this code goes back 24 years or so. And so anyways, it's good to add that safety feature. I know that it aligns with what Mark has been doing with the new JitBuilder. I think you spent a few days doing const correctness, making those APIs const correct. So good that there's some good places. Okay. But yeah, so it's good.
Were all the changes that you had to do, did they all just kind of work naturally, or was there anything that stood out as not really, like something where you had to do more than you thought you should need to do?
A particularly nasty section that I had to work on was OMR options. I'm sure if you've ever seen OMR options, you see all of the structs where each of them has the name of the option, and they're all string literals, and so there were a lot of changes involved in that, because changing the the type of the field in the struct, and then basically every function that's involved in OMR options had to be updated. So that was a particularly large section, and that's why control is one of the bigger components in terms of lines changed.
Mm-hmm. You'll complete it before you go?
I'll try my best.
It's ready.
Yeah.
Yeah, things will start landing over the. I mean, they already are landing, but we'll hopefully get that wrapped up, and then we'll flip the switch on warnings of errors. There's for power, and then we'll have some pretty good.
So one platform I might suggest that you try on is building on Mac, where it's playing in a relatively new version of playing. So
right. Has the
one
compiler
that's
been
often quite
incremental,
pedantic about
interesting? Yeah.
Const correctness.
I believe I've been building on Mac. In fact, that was when I spoke of the one warning that was left on ARIC64, it was a single warning on ARIC64 Mac, and I have been building on there as well, so it should be fine.
Yeah, okay.
What were the situations where you had in a cast?
Right. So there were situations actually in OMR options where there were certain functions that take a mutable reference to a char pointer, and in order to make that const, you had to double const it essentially, but they needed to be mutated in there anyway, and so you had to those functions where you were passing a reference, they were mutating the strings in there, and so you had to pass in you had to temporarily cast it to mutable before you can take it back out and reassign it to a const pointer, things like that. Basically situations, where you need to mutate the actual characters being pointed to by the pointer.
So there's situations where we're writing to, like, we're modifying string literals?
Not necessarily literals, but
if you looking at the case where it shouldn't be const.
Yeah.
Right.
Yeah.
Like if you're actually mutating it, it's not really const.
Exactly. Yeah.
So, sorry, can you talk a little bit more about this case?
And this is still to be reviewed, so there can be discussions on that at a later date when that occurs. But there was a layer of OMR option. The way that I conceptualized it anyway was that there was this layer in which you can't mutate the string within this function. You can pass it. You can pass a mutable version of it into a deeper layer and let that handle the mutation, and then take it back, and then trust that you aren't going to mutate it further. To be able to talk more eloquently about it, I would have to go back and look at the code again, which I can do, and we can have further discussions about that if there's a concern. But,
does that mean you had to do const casts around some of those uses, or how did you manage that?
I just did a regular cast to char star. I wasn't aware of is there a special const cast?
Yeah.
Interesting. Maybe I should be using that instead.
Does our all of our compilers support?
Maybe not.
So you just did the C style casting.
Yeah.
Okay.
That sounds dicey to me.
Okay.
I think that's like, I mean, if a lower layer is changing something and an upper layer is not, if it needs to pass in a mutable pointer, it needs to be a mutable pointer. It is mutating in that context.
Fair enough. Yeah.
But, I mean, I understand the desire.
Mm-hmm.
other discussion you want to have on this?
Probably not relevant to the external OMR, but for ZOS, we have similar issues about warnings. Or
Yeah, he's been testing it on ZOS as well.
oh, ZOS.
Why is that not relevant to the external?
I don't know. Because we don't
build
build.
OMR on ZOS.
Yeah.
In the
Oh, we do?
Yeah.
Okay.
not OpenGNOME, but OMR would do.
Okay.
Okay. All right. Thanks very much, Lynn. That's good. All right. Let's move on to sort of a late-breaking topic today. So James has been looking at intrinsifying some of the unsafe. This is a Java, obviously a Java thing, but the symbols reach back into OMR. So he wanted to have a discussion around some of the thinking that went into the JIT atomic symbols from a design a couple of years back, and we seem to have ended up with two implementations. It's a very common theme in the JIT, I think, but two implementations of one thing, and we want to decide on the right path forward here. So anyways, James, I'll turn it over to you. Take us through this. I think you're on the call.
Yep, I'm here. You can hear me.
Yep, you can hear you.
Okay. Should I share my screen or anything? I didn't prepare anything because it was such a...
Sure. If you have something to share, otherwise, I don't know.
I was just going to share the pull request where it all started.
Yeah, sure. Just take us through it. Yeah.
Oh, actually, my WebEx is not set up to permit sharing, so if you could just share it so I don't have to restart and leave and join.
What number do you want?
2958, the one right there.
Yeah, let me find it. Just 1 second. All right, how's that?
Okay, that's fine. Yeah. Okay, so I've been trying to implement some new intrinsic methods in the unsafe library that's now part of OpenJDK. Instead of the miscellaneous Sun package, it's in the JDK internal package. And part of the changes that they've made, most of the methods from the Sun package translated pretty much isomorphically to the JDK package, but they added some new methods for byte and short. And so these byte and short methods let you do things like an 8-bit atomic fetch and add and a 16-bit atomic fetch and add. And those are things that historically we did not support. And they translate well to x86, but not on platforms like Z, which is where we kind of hit a roadblock on what to do, because Z doesn't have a 8 or 16-bit atomic fetch and add. And I was talking to Rahil, and we thought about writing a routine to emulate it, but Z also doesn't have an 8 or 16-bit compare and swap. So we kind of hit a block there, and that kind of led me back to these symbols, where these symbols, we have many of these symbols. So prior, we had a symbol for each bit width that was supported for these type of intrinsic operations. One, if you have an atomic fetch and add, it would end in 32 bits or 64 bits. And this change, this pull request 2958, introduced a generic symbol, which was, instead of having the bit width at the end, you just had the symbol itself. And by having the symbol, it implied that all the backends had to support any varying number of bit widths. And so that kind of led to the point where I wanted to stub out or temporarily disable compilation for byte and short atomic fetch and adds on architectures where it was not trivial yet to implement them, but support them on architectures where it was trivially mapped to an instruction. And so the trouble here is when we introduced just generic instruction, we did not remove the older ones. And so they currently both exist. And I'm stuck at a crossroads where I have to make a decision on, should I add more bit widths to make stubbing them out, more trivial, or should I follow through on coming up with a way to support a generic symbol, but then figure out ways to stub them out depending on, whether the type of the operands is supported or not. And that seems like kind of a major decision that I shouldn't just make in isolation. So I thought it'd be good to have that as a point of discussion.
So these symbols eventually become call nodes that, and then you just hang, the children of those call nodes become whatever type you need to deal with. And then it's then up to the back end to figure out, based on the type of the children, what operation it maps to. Is that right?
I think so. Yes. Yeah. I guess the two decisions here, should we remove all the symbols with the bit widths at the end, or should we follow through on having a generic symbol? Because this issue still remains open, and it was open 5 years ago.
The actual change that introduced the generic ones was 2999.
Oh, right, yeah. This is actually just an issue, not a pull request.
Right. I was thinking, did we discuss this already? I'm trying to remember. It's been 5 years. Did we discuss this already? And we're going to deprecate that use a generic only for all data sizes. I guess the other thing is, what is the? I'm not familiar with all the symbols that we currently have. Are there other examples where we have symbols of a certain data type?
I think that list is what I've seen so far: atomic add, atomic fetch and add, atomic swap, and so on.
I was going to ask a slightly different question. Do we have other examples of symbols where the size of the memory that's referenced by the symbol is actually determined from some other place?
Yeah.
Like the data type of an operand? That just feels weird to me.
Meaning that you're advocating the explicit.
I'm not advocating one way or the other. I'm just saying it's weird to me that the symbol doesn't know how big the thing is. Like the symbol itself does not reflect the size of the thing that it's a symbol for. That feels odd to me. In part because, like, when we're aliasing, we're talking about symbols primarily, right? Not symbols combined with some data type off of an operand sitting somewhere.
So I haven't looked at any of these issues, but presumably the reason why this was done in the first place was they wanted to pull all this into OMR, because otherwise you could have left it as recognized methods that get recognized, no special symbol for it. It is whatever it is in the bytecodes. You just generate a normal method call. You recognize, we do that all the time, right? There's no shortage of methods that are recognized in special cases.
I think the reason it might live in OMR is just because of the refactoring, the table of symbols lives in OMR. That's what I would think.
No, but somebody went out of their way to create n symbols, right? Like atomic add symbol, for example. Like, why couldn't you have done this using why couldn't you have done all of this using recognized methods? And one answer, I'll give you an answer to it, because that would be OpenJ9 specific, not OMR centric. But was that really, like, is that worth all the other complexity that we're now, like, I guess I should go through these issues. I wasn't aware of this at all, so. Yeah. I can tell you that in the past, we did not do this kind of explosion of method symbols for this kind of thing. I think it's just slightly uncharted. In fact, I can't even think of another example off the top of my head where we do this sort of thing.
One thing that's different in that's changed since then is the list is now down to just the two methods I had to change, which was atomic swap and an atomic fetch and add. The other three symbols now only have the generic versions remaining in OMR. So I think some progress was made since this issue was open, but it's still incomplete. Progress as in, changes were merged that pushed us towards just having a generic symbol rather than having, varying symbols of different widths.
Yes, going back into the old design philosophy here, just to put it out there as well, is if you wanted to do something like this in OMR, we would have created opcodes back in the day to do it, rather than have like this sort of weird in between that we have here. There's a call, but it references some other method symbol that wasn't there from the ILGen. It's not common. So there better be a good reason for it, because I mean, it's a bit of an uncharted territory, and do we even need this kind of notion is the question I would raise. I'm not sure that's a question that's directly related to what James wanted to discuss here. I'm making more of a comment about all this to begin with.
Yeah,
oh, go ahead. Sorry.
No, I'm just thinking about the history here is a little bit choppy.
That's what I'm
saying. That we have a inconsistent use of some of the, or inconsistent way of implementing some of these kind of features. Like we don't have compare and swap is not an opcode. Yeah. Maybe that would be a discussion to have here at some point as well. Maybe that's a valid discussion.
I think, I didn't realize this was a third option, but having it as an opcode is also a valid point.
Maybe the answer to my questions are in these issues somewhere, so I should just go through.
Maybe I haven't seen them either until now, but and I don't remember discussing this at a architecture meeting if we did. I'm trying to reconcile your statement about generic symbol and Mark's statement about, or at least his concerns about, or observations about the symbol not knowing its size.
I mean, these are like methods.
Sure.
They're methods. The only use that I know of is atomic stuff in OMR, actually, JitBuilder. I remember we used it in the Swift. The Swift JIT, we needed the atomic support for doing the reference counting. So there actually are there's like an atomic add operation in JitBuilder.
So you implement that as a method call, though, that would get recognized by the
I'm looking at the code right now. It's using that atomic add symbol to generate a helper call. It just passes the base address and the value to it.
Well, I mean, I guess you're looking for some clarity here, James, to know which path to go down.
So how would the aliasing work for one of these things? Would it just basically, like, nothing would be able to move past the hole? Or
depends on the semantics of part of the problem, I think.
Right. I mean,
Like, what is the spec for a call of this? Who defines the spec for it?
In some sense, it would come down to, I mean, the way that it is right now, I think it would come down to what the front end, the consuming language defines it to be. Like OMR does not.
It implements it.
It does, but I mean,
it's not as big a deal because it's an atomic anyway, so you probably shouldn't be moving anything from atomic access. You can use atomics to implement blocking. So.
But is that actually true on all platforms? Like there's fences on power which separate the
true.
semantics from the actual compare and swap.
True.
Why I think this is all a bit shaky to begin with.
Yeah, I feel comfortable. I feel more comfortable for someone in the room who could explain all of that.
Do we have to? Can we bring it back? Like
yeah, I think I was just going to say to James that I don't think there's enough confused faces in the room here that I don't think that anybody's comfortable enough making a what to do here. So we'll have to give this some thought offline, I think, and then
okay. I think
come back.
Yeah, I can also do a survey on how these various operations are actually implemented on the underlying architectures, because I think at first I thought it could be an opcode since nothing could move past it, but I realized, it could be implemented with more than one instruction in some cases, like with a fence. And yeah, okay. I think that's a good idea. We can pin it for the next meeting.
Right, but we certainly don't have to wait until the next meeting to make a decision on what to do. I think it's maybe just coming back to the group here and even just saying this is what we decided to do based on discussions that we had in the issue or in the community, that kind of thing. So
okay, sounds good.
But the investigation that you had just mentioned, I think, is good to do to give us information to work with.
Right. Okay.
Does anybody want to inject anything into this discussion right now? Okay. Thanks, James. We have one more topic for this afternoon. So Mark is going to give us an update on JitBuilder 2. Do you want to just talk, or do you have?
I have a couple of slides. Well, it's a little more than a couple. I'm going to steal the screen share.
Yep.
Okay, can everyone hear me? Okay.
Yep.
Okay, good. So I forgot how many of these presentations I've done. I think it's something like the fourth one. Today I was gonna just kind of remind people again about JitBuilder 2, because I know I've been here for a couple of weeks or a couple of months talking about this stuff. So remember, JB2 is kind of an improvement upon the existing JitBuilder component to try and make it easier for people to use it in the context of the OMR compiler, to improve things like how you reason about what you're actually doing with JitBuilder, how you can use it as a more fully fledged compiler implementation as opposed to just an API that is it passes through things into the OMR compiler. Still does that, but it creates things now at the sort of JitBuilder layer that matches your mental model of the calls that you're making, and with the goal of basically producing an extensible compiler framework. It's sort of analogous to what MLIR is for LLVM, but I have other wilder and crazier ideas for it going forward that I just haven't gotten to yet. So that JitBuilder 2 framework, I've been at this meeting a number of times and gone through a lot of details. So I'm not going to go through any more details on JitBuilder 2 in this meeting. In fact, it's mostly the case that I haven't had much time in the last couple of months to work on it much more than where it is. So it's not actually very much further advanced than what I was talking about the last time that I was here. However, I did want to cover a couple of topics. I thought I'd go through a little bit more of what the code structure, like kind of where things are falling in the directories and how they fit into OMR. And I have a proposal at the end of the talk on integrating this into OMR that I want to get people's feedback on, because it does fly a bit in the face of how we do things in OMR right now. So I presented some of this before, but I'll just go through it again. So when I created JitBuilder 2, basically I took the whole JitBuilder directory, which is an extended compiler of the OMR compiler directory, and basically copied it to a new directory called JP2. So I created a new JitBuilder-y thing called JitBuilder 2, and basically the reason for that was so that anything that I had to muck about with in JitBuilder wouldn't affect the actual JitBuilder library. So if anyone's using that, then I wouldn't interfere with that. And then I removed a bunch of stuff that I didn't need, like the LJB stuff and a few other things. I created a special directory in there, which is API for lack of a better name. And that's basically where all of the new stuff that JitBuilder 2 implements introduces things. I have integrated everything into the whole CMake structure. So there's the new CMake flag -d OMR JB2. If you set that to 1, it will basically include that whole JitBuilder 2 directory, including the API directory. It also depends on the OMR compiler, so you need to build that too. And then there are a few extensions that I've already created, JitBuilder 2 extensions that exist inside that directory that get built automatically. I've now added some specific flags that you can enable other extensions or specific extensions to be added. It's a little bit more flexible, and most of them have their own tests, although I will not claim in any way, shape, or form that they're complete. Mostly they're suggestive rather than comprehensive in any way, shape, or form. When it builds on Linux, it runs all of the JitBuilder 2 tests by default under Valgrind, with all of the extra options to make sure that there are absolutely no allocation leaks that are happening throughout the compiler, which is kind of nice, but unfortunately I can't do that on my MacBook because it doesn't have Valgrind, so it doesn't run that way when I'm normally developing with it now. A couple of side notes here. So JitBuilder JB2 uses a different code format than the rest of the OMR compiler, which of course is different than the code format than the rest of OMR uses. So this would be a third code format. However, the code format that I used is roughly based on the one that we discussed when we went through the last round of could we change our code format in OMR to be something a little bit more modern looking and maybe uniform across all the components. So one of the exercises that I did with JitBuilder 2 was to actually try out developing with that code format to see how I felt about it. And it turns out I'm happy with it. But of course, I'm happy with all the other code formats too, so except for the ones that use tabs. But anyway. I think since the last time I was here, I can't remember if I talked about this the last time I was here or not, but I did make the modifications to the make files in order to be able to build on both x86 Linux and on AR64 Mac OS. So I started building on my laptop again, which was kind of nice, on my laptop rather than on some other laptop where I was running on a Windows Linux subsystem and carrying 2 laptops with me everywhere. It's kind of awkward. Good exercise though. And currently its home location is actually in a branch on my fork of OMR. So kind of an awkward place for anybody other than me to go, regularly doing anything with it. just give you a little bit of a flavor, I think I've shown this in one of the demos I did last time, I think, but just to give you an idea that like that JB2 API directory, all of the sort of core classes of JitBuilder 2 are all present there. These are just a list of CPP files that are in there, you know, defining all of the compiler, compilation, config, context, scope, literal, symbol, operation, all the sort of wonderful things that we, as compiler developers, are fairly familiar with the names, I think. And then the extensions, each extension gets its own directory underneath this API thing. So there's, as I mentioned, there's kind of four, I won't say complete, but they're the ones that get built by default, and they represent a lot of the functionality that the original JitBuilder API had. Not all of it, unfortunately, because I just haven't gotten around to doing it, but I've made it easier to actually do that recently. So base, for example, it includes some of the core operations from JitBuilder, like all of the base arithmetic operations are there, which by all I mean add, sub, and mul. Load and store are there. The ability to load fields out of structs and define struct types and pointer types and all that sort of stuff. All of that is there in the base extension. Func is sort of a subset of what was in the original JitBuilder thing. It's basically providing the support for creating C-like functions and compiling C-like functions. So the idea is that JitBuilder 2 doesn't necessarily force you into a I'm calling C functions or trying to generate code for C-like functions like the original JitBuilder did. But everything that actually uses JitBuilder right now does actually use that. So it's aspirational, I guess, but it has been factored that way. One of the interesting things that proved out some of the extensibility mechanisms in JitBuilder 2 was the JB extension. So I mentioned that when you build JitBuilder 2, you have to build the OMR compiler, and that actually builds the JitBuilder API as part of it. The JB2 compiler actually contains no code itself that calls JitBuilder or OMR compiler, or it can be built, in fact, independently of OMR. The only piece that actually references anything in OMR is this JB extension. And so it knows how to convert basically anything into JitBuilder calls, and it implements a code generator which gets dynamically injected into the JB2 compiler, so that when JB2 wants to generate code, it can direct that into this JB extension, which then uses the OMR compiler to generate the code. In principle, you could do this for other things. The two that I'm sort of notionally thinking about and have spent a little bit of time thinking about would be a direct to OMR IL extension, which would work the same way as JB, just cut JB out of the picture and go directly to the OMR IL. And the second one is an OpenJ9 IL one. So one of the challenges that I ran into with the original JitBuilder API was when I tried to use it inside OpenJ9, I was reminded that a lot of the base core infrastructure of the OMR compiler is not actually reused by the OpenJ9 JIT compiler. So things like front end, concrete FE, and a bunch of the memory stuff are not actually, the OpenJ9 doesn't use the OMR stuff, it has its own stuff. And so that difference causes all kinds of pain trying to reuse JitBuilder in that context. And so in this model, you could actually design, you could have two different implementations for how to target OMR and how to target OpenJ9, and it can take advantage of / tolerate the fact that those things are all different between the two execution environments. But you can unify it under JB2. And then VM is where the virtual machine emulation supports, so things like virtual machine operand stack and the ability, basically for the ability for the JIT compiler to privatize virtual machine state within the context of the method that it's compiling. So you don't have to actually manage all of or directly update the virtual machine state all the time. There is a sample directory, which I reminded myself of recently, but I haven't built it in a while, so I have no idea if it works. Probably doesn't. But it basically has a matrix multiply. Matrix multiply was one of the standard samples that I used with JIT that I first wrote when I was doing JitBuilder. It was actually the first thing before I wrote JitBuilder, I wrote the matrix multiply JitBuilder sample and then built JitBuilder around that. So I've done that too for JitBuilder 2. It's just JitBuilder 2's kind of moved on since I wrote that initial sample. So I'll get that back to working eventually. And there's a whack load of test directories underneath all these things. So the main API directory has a test directory under it, which contains tests for the core JitBuilder functionality. It does a bunch of unit testing of compiler, of the extension loading mechanisms, of some of the core container classes like BitVector and list. So it does those, it runs those tests as unit tests outside the context of running a JIT compiler, which is one of the things that I've always wanted to have for our JIT compilers, but it's not easy to do in OpenJ9 or even in OMR. So that exists, and then each of the extensions themselves also has a test directory. Maybe not all of them, but some of them do. And far from complete, but at least indicative and suggestive that you can write tests if you are so interested, which I am. So I've talked about these in the past. I added them to the presentation, but I don't think I really want to go through them because it probably calls to mind a whole bunch of things that I've talked about in the past but haven't talked about recently, so they may not be all that familiar to you. So I'm just going to skip these. But the one thing I'll point out, so there is a core extension that JitBuilder has. Like when you define a compiler, it has a core extension that provides a few simple things, but then everything else you have to load special extensions to do what it is that you want to do. So it's quite similar in this nature to MLIR and how it works with dialects. This is the JitBuilder one. That's the VM guy. There are some extensions that have been actually created but are not complete or even in a sort of semi-useful state. Debug is one that I was working on for a while, trying to get the opcode debugger back, the IL debugger back in place. I am still hoping to do that at some point. I don't know if I'm going to get to it this year now, but I'm still trying to do that. Complex is something that was, again, part of the original matrix multiply code sample. Was one of the proof points for JitBuilder 2 was that you could write code in JitBuilder 2 that you could handle matrix multiply on floats or doubles, or you could define a complex class and run the matrix multiply code on that, and it would just kind of work. That's not in that state just yet, but it has worked in the past. It's just a matter of getting it back into shape. I'm going to talk about Vim. The next ones are more sort of imagined things. So one of the drawbacks of JitBuilder as a whole, actually the OMR compiler, or like OMR as a whole, is that there's almost no integration between the compiler component and the GC. All of that exists in OpenJ9. So all of the stack maps and register maps and all of that stuff that we know and perhaps love, mostly hate, about the interactions between what it is that the JIT compiler has to generate in order to get the GC to be able to walk a JIT frame and understand what objects are live and what their types are and all that sort of stuff. How to handle exceptions, all of those kinds of things. I guess that's not really a GC thing necessarily, but all of that stuff does not really exist in OMR. And it really doesn't exist for JitBuilder because JitBuilder uses system linkage, and we haven't defined any kind of sort of interface between the GC and the JIT for native stack linkages. So we just have, all kinds of address things are not, contiguous in the stack frame. They're not. There's no information passed to the GC about what things are live at which points, etc. So it'd be nice to have an extension where we started to define some of those things. And, the general notion there is you could introduce a managed address type that would be a way of sort of having this all work through JitBuilder 2. Interpreter builder is another sort of key thing that I'm hoping to build at some point. We've had sort of early prototypes of this done by some of the folks in Ottawa in the past, where you use JitBuilder to produce an interpreter, basically. With JitBuilder 2, I think it gets, it's an even more powerful concept, because essentially you can imagine creating a compiler that is designed for building interpreters. So generate the code for an interpreter, right? And you can, you know, write code to generate different kinds of interpreters and even transition between them. And then if you have all of the stuff in your hands to be able to build the interpreter, you can also automatically build a JIT compiler, that's kind of as far as those Ottawa folks got with some toy languages. They managed to write, you know, 600 lines of JitBuilder code that would produce a simple toy interpreter. And then it could also generate a generic JIT that would run from that same 600 lines of definition code. So it's a pretty powerful concept, but we haven't been able to take it very far. But I think JitBuilder 2 is the right place for doing that. So I'm hoping to get there eventually. I mentioned OMR and OpenJ9. I've been doing some research projects with people from DB2 and people from UNB on compiling for SQL. So I've also sort of have bits and pieces of a SQL extension for writing a SQL compiler using JitBuilder 2. But that's not very far along. All right. So I'm basically at the end of my little spiel here, but so I've made lots of progress here, I think, over the last year, but there's still lots to do, and I think I'm basically the limiting factor. Not that I'm expecting a whole bunch of people to jump up and start doing things in this space, but the fact that it's sitting on my branch and often is sitting in a local version on my laptop means it's hard for people to really get involved in, even if they're interested to. So anyway, so it's you know, it's starting to get to a fairly largish size. CLOC says it's 28,000 lines of code right now, which includes all of those incomplete extensions in little bits and pieces. But that's probably more than it has to be, but it's not a lot larger than it has to be. So I wanted to start a discussion on trying to merge this thing into OMR, but I think it's still at an extremely prototypical stage. So it's not something that I expect anyone to use for anything right now. But I'm mainly trying to use OMR as a way to encourage or support collaboration where it would be possible. But I recognize that if we were to manage this JB2 thing, merging it into OMR the same way that we manage all of the other code in OMR, it would become impractical, right? So for example, just looking at how I've been working with JitBuilder 2 over the past, there are times when I have very well-structured pull requests that are making, a commit in a little space and making that change. There are other times where I've changed almost every file in the whole thing, like all of those 28,000 lines of code. Not all of them are changing, but maybe 8 to 10,000 of them are changing at the same time because I'm doing some wicked refactoring across the whole thing. And asking one of the committers who I know are already busy with all kinds of other things to review an 8,000 line code change in a prototype implementation just doesn't make sense to me. So, this is the main reason that's been holding me back from contributing it to OMR, is that I didn't want to place any undue burden on the people who are working at OMR already and doing quote unquote real things, not just the things that I'm playing around with JitBuilder 2. So, I guess I would like to get it into OMR, and I think there's some value to me to getting it into OMR. I don't think there's a lot of value to anyone in this room or probably on this call to me doing that, but I wanted to run an idea past everyone and see how it grabs people. So the proposal was to merge it into the master branch for OMR, but because it's all relatively self-contained within that JB2 directory, I think that there's a potential that we could allow for having different rules apply to what's happening in that directory. And so while I'm perfectly happy for people to review the code and look at the code and give feedback and even submit PRs and commits and make changes to it, I was imagining that we would relax the requirements for reviews on PRs to that directory for the time being. That's part for me and that's part for you, right? So the idea was that at least I would be able to self-merge into that JB2 directory. And And I would promise that if there's anything that I have to change outside of that JP2 directory, that I would obviously go through the regular cycle of getting reviews from people and making sure that the changes are appropriate from the project's perspective. But if it's something that's contained within the JP2 directory, I would basically take ownership of the responsibility for making that change and manage it. If someone else contributes something, I'll happily review that change and help that get in. But,
what is the does it have to be in the master branch, or what is the advantage of having it in the master branch?
So that's another alternative. We could create an incubator branch, an incubator branch, and we could manage it there.
Like if it is independent of the rest of OMR, it's just
So that's another alternative. Let's see, pluses and minuses of that. Because there's no real downside of that. You're right. It doesn't have to be in the master branch.
So you have to make sure you update that branch, like rebase it all the time, or like merge back.
Yeah. But that would be the main disadvantage. Would be not picking up.
The other thing I was thinking of was that the reason I'm on the con side of having master is because all those changes will end up in the history of OMR that you're going to have. The other thing that may be a possibility is if you have something similar to what OpenJ9 does, which is the OpenJ9 utils repo, where if you create another repo owned by OMR that has incubator projects essentially, and then if you configure such a way that in order to build this guy, you have to pull in OMR and build, that could work, and then they'd be separate histories.
So I could do it as an overlay, is what you're suggesting, basically.
Yeah, it would. I think in OpenJ9, it's part of the Eclipse OpenJ9/utils or something.
OpenJ9 utils.
Which all the committers of OpenJ9 are also committers of that, so it could be a similar idea. Until you are ready to
actually work. Okay.
That way you don't have the issue of the master branch merging constantly.
Well, I mean, I'm paying that cost right now anyway. So it's not yes, it would be nice to get rid of that. I agree. And to be honest, it's rare for that to bite me because I'm not usually making changes outside of that JP2 directory, and nobody else is making changes inside the JP2 directory. So it's not like there are merge conflicts.
Right.
And then I can't remember the last time that somebody broke me just because I'm not doing anything, sort of. Well, I do wicked things, but but not things that anybody usually breaks me on somehow. I am pushing the OMR compiler in a bunch of directions that it didn't anticipate being pushed in, but I haven't been broken in recent. As maybe once the debugger gets up and running again, that might be a pressure point on that sort of thing.
I wonder if not having special rules just for JP2, but rather us deciding on what we want to do with some incubator projects like this, might make it a little bit more generic. So, for example, rather than if you did the master branch approach, we created an incubator directory, you would put JitBuilder 2 under there, and the rule would be if it's under incubator, you don't touch it kind of thing.
Yeah, that's fine. Yeah.
Or if you want to go the utils, we would create an incubator repo under OMR where those projects like this could live.
The downside of the incubator idea with OMR is one, Eclipse would need to create it, but two, for OMR we don't have an OMR what's it called, organization. Yeah. It's still Eclipse/OMR.
So Eclipse would have to do everything.
There's a lot more info work, but so it depends on.
Well, we could create a organization like the OpenJ9.
Yeah. I'm just saying the downside of doing that would be all this info work that I'm not saying it's a bad thing.
It's a bigger change than just.
Yeah, I'm not saying it's a bad thing per se. It's just a discussion point as well.
Yeah.
Yeah, my only concern with master is just the history. I know you said it comes in spurts, but just in terms of that, as long as it doesn't muddle the history too much, it does
So, I mean, one of the reasons why I'm coming now and not in the last year is that I'd like to believe that the core APIs are starting to stabilize at this point. So I'm hoping not to be doing, you know, wicked refactorings of it where I'm changing everything over time. And being in the master branch will also force me to be a little bit more rigorous in how I'm managing my changes, because I would be ashamed to deliver some of the, like, if you were to go and look in the history of the JP2 branch in my repo right now, you would be appalled at some of the things that I have in there because I'm appalled by some of the things that are in there. So, you know, that's one of the reasons why I'll squash everything. And plus, there's probably at least 5 or 6 commits that are basically like change everything. So it's like the history is not even worthwhile at this point, really. But so the history one, I'm of two minds. I understand you're concerned with it just because you don't want the history polluted by a bunch of stuff that's kind of going on in an incubator project. The flip side of that, I guess, is if we believe that JitBuilder 2 is something that's going to be part of OMR and it's going to become an important part, maybe, luckily, if I'm lucky, that way, an important part of OMR, then maybe capturing that history is sort of important, right? And you know, I can do things like tag the history lines. You know, we've done that before with JitBuilder stuff too, right? Like I can put a JP2 thing at the beginning of every, so other people can ignore it if they want to. I don't expect there to be like, you know, Mark puts 8 PRs in a row onto this into this branch and distract everybody from the history that's going on around him. But just because I don't usually get enough time to sit down and make that much change in one short period of time. So it's more likely that you'll see a periodic JitBuilder 2 related history item.
The one thing that,
notwithstanding Christmas is coming, so I might be able to do more. But anyway,
yeah, the one thing about the master branch approach that, I mean, I get the thing with the history, and I wasn't too. It's the self-merging aspect, which we're now bending the rules to allow merging directly into the master branch without, which I certainly respect your.
I understand. I guess a concern with that too.
Well, I'm trying to think about the precedents and that we would be setting for these kinds of projects, because someone could show up in the near future with some other idea and they say, look, Mark got all these rights and privileges, rights, but you got privileges. I have the right to merge without.
I'm a project lead. So how many project leads are going to show up and do this?
Yeah.
Charlie could, in principle.
That which maybe leads me to think that having another repo or a branch might be a more palatable thing.
We do have. I mean, it's not like having another repo is a precedent setting, right? Doesn't the website have another?
Yeah.
There's an OMR website.
Yeah.
Repo as well that was created.
Yeah.
So we could just ask them to create an OMR incubator.
Right.
I don't think it should be a JP2 specific. I agree with your notion that should be an incubator.
And in that incubator, we can relax the rules.
Yeah, go nuts.
Go nuts.
Right. As long as you're a committer. Committers can go nuts.
I don't think anyone else would have write access anyways.
That's what I mean, yeah. Only committers that would be able to go nuts. We're all written nuts anyways. Okay. Yeah. So what would that mean in terms of like being able to run, say, pull request testing on, like, the other advantage of being able to merge into the master branch in the main repo would be I could actually run, if I wanted to, I could run the pull request testing on.
Yeah, I mean, some of the CI infrastructure, I think we should be able to adapt it to point to a different repo. And if it's not that way, then I think we could probably change it to be that way.
The next question is how much work is that going to be?
That's maybe an Adam question.
I can look into that. Let's see what the impact of that would be. Okay.
I mean, like you said, on an incubator branch, you're maybe not expecting there to be a lot of rapid fire pushes, which mean that you may not, unless we don't do automatic pull request, you have to launch it yourself. When you're ready to do that, maybe that's the.
Yeah, I think it's probably better to set up an incubator project that way. Yeah. That it only runs testing on demand, so you'd want to turn off the like the Azure testing that happens by default.
GitHub Actions and all that, or some of those.
That's actually supposed to be best practice anyway for for a repo to do that. We probably shouldn't be doing that, frankly, because it's too easy for somebody to check something into the repo that then takes advantage of the fact that there's code that's going to run on Azure. Shouldn't say that on a public call. Tell everybody how to hack our repo.
Okay.
Okay. I will. The feedback heard. Thank you for entertaining the idea. I'll go back and I'll talk to Adam and see more about what it would take to set up an incubator's repo and manage it that way. See what that's going to do.
I will say that if we do go down the incubator repo to make a OMR its own organization, because now there'll be 3 things. The website, OMR itself.
Right.
Yeah. I mean, not related to this, but we have other project kind of things that we need to, like, I want to start talking about releases again. I have the homework to read through all the Eclipse rules and procedures on there. Yeah, to figure out, because we have to go through a review. I can't remember the name of it. They have a name for that, but they have to review our project, basically, to see if we're following the rules that we are supposed to be following.
It'll be more work for the next release we do. I mean, depending on how long it is between releases, it's like you have to collect all the stuff that happened since the last release, basically.
Yeah.
I remember going through it for the first one.
So something like that, and then our own organization, maybe an incubator repo. Anyway, it'll be exciting to get this merged, hosted.
I guess So the other reason why I was thinking to put it into the master branch, forgot one of my reasons for wanting to do that was that it. I mean, it's not impossible, but it made it easier to start thinking about an OpenJ9. Having an OpenJ9 specific, writing an OpenJ9 specific extension, which would live in OpenJ9, but then leverage the JitBuilder 2 implementation in OMR. I mean, I can always change the OpenJ9 thing to pull from the incubator's project, I guess. It's not that much different.
Because that in itself would be an incubator project.
Yeah, I guess that was a little bit about how we were going to manage that incubators. I mean, maybe again, it boils down to branches, like a branch per incubator, which would mean you could
incubator repo, and then each project gets its own branch.
Yeah, like the repo, you could still pull from, like if the incubator's master branch could still be rebasing on the main repo, but then you could have a branch per incubator that you could then individually rebase from the master. And then that would at least still keep the repo in the same basic structure as OMR itself. And it also makes it easy to eventually deliver it into the main repo if it optimistically ever gets good enough.
I think for OpenJ9, like if this ever gets out of incubator in OMR, like I think OpenJ9 just becomes an implementation. I don't see too many incubator projects in OpenJ9, right? Whereas OMR does feel like it has more potential for OMR has all the infrastructure. I just have to extend it. That'd be it. So, might be a bit simpler.
I think you're convincing me that this is a better option than the direction I was going for easy. But I think this is probably a better suggestion. Okay, I'll go off and research it.
Any other discussion we want to have on this topic? We're getting close to the time here.
I'm good at hitting the end of the meeting.
Closing the turn the lights off. Okay. All right. Thanks everyone who presented today, and thanks everyone for attending. Our next scheduled architecture meeting is 2 weeks from now. So the agenda is already there and ready to accept your proposals. All right. Thanks everyone. Talk to you later.